Welcome to Math with Mrs. Seeley. Let's get started on this 2021 free response question number 5. The question says to consider the function y equals f of x whose curve is given by the equation 2y squared minus 6 equals y sine x where y is greater than 0. A part says to show that the derivative is equal to this expression. So I need to take the derivative of this right here to prove that it equals this. I want you to notice that you are going to have implicit differentiation because you've got two variables. You've got x's and y's in the same question. So if I have 2y squared minus 6 equals y sine x, let's take that derivative. If I take the derivative of 2y squared, that's going to be 4y, but because I took the derivative of a y term, and this is implicit, I need to put my y prime in there. Of course, the derivative of 6 is just 0. It's a constant. Here, I'm going to take the derivative, but it's going to be a product rule, where this is my first and this is my second. So the product rule says the first, which is y, times the derivative of the second, which is cosine x, plus the second, which is sine x, times the derivative of the first, which is 1, but because it's a y term, I'm going to have to put in that y prime. If you were able to do that successfully and differentiate that implicitly, give yourself the first of those 9 points that this essay question is worth. To continue to prove and show that it's equal to what they want us to, we need to solve it for y prime. So I'm going to subtract sine x y prime from both sides, because we need to have y prime by itself. So over here I have 4y y prime minus sine x y prime is equal to y cosine x. Now let's factor out the y prime and have 4y minus sine x in parentheses equals y cosine x. And then I will simply divide and get 4y minus sine x to divide on this side. And I will divide by 4y minus sine x on this side. And then I'm able to show that that's what y prime is equal to. If you were able to do that successfully, give yourself the second of the 9 points. All right, the second question of this question, B part, says write the equation of a tangent line. So we know if we're going to write the equation of a tangent line, we need to use our y minus y sub 1 equals m times x minus x sub 1 formula. We have the x and the y right there. That's what we're going to plug in for x, what we're going to plug in for y. But we need our slope. And to get slope, remember that's the derivative. And they told us the derivative, and we just confirmed it, was y cosine x over 4y minus sine x. Okay, so let's go plug in our values here. So where y is, I'm going to put in the square root of 3. Cosine, where x is, I'm going to put a 0, over 4. Where the y is, I'm going to put in the square root of 3 minus the sine. And where that x is, I'm going to put a 0. So let's kind of evaluate and clean this up. Because we're going to need to find the sine and the cosine values, we're going to need to look at our unit circle. At 0, which is right here, that's the ordered pair 1, 0. If you will recall that you know that your x coordinate is your cosine value, your y coordinate is always your sine value. So then that tells me that I will have the square root of 3, but the cosine of 0 is going to be 1. So that's going to be the square root of 3 times 1. And then 4y, that should not be the square root of y, it should just be y. But where that y is, I'm going to put in a square root of 3. Minus the sine of 0. The sine of 0 is going to be 0. So that I have the square root of 3 over 4 square root of 3. Cancel those. And my slope is 1/4. Now let's come over here and write the equation of the tangent line. Y minus y sub 1 equals m times x minus x sub 1. And you could leave it there. They would accept that. I think I'm going to go ahead and just add that square root of 3 over. So I'll have 1/4 x plus 0, and then add over my square root of 3. That is the equation of the tangent line. And if you were able to successfully do that, give yourself your third point of the 9. All right, C part says, when x is between 0 and pi and y is positive, find the coordinates of the point where the tangent line is horizontal. All right, let's think about something. Tangent line being horizontal means that you're going to have the derivative equal to 0. When you have a horizontal tangent, the derivative is equal to 0. So we need to take the derivative that we just had, the y cosine x over 4y minus sine x, and we need to set it equal to 0. If you knew to do that, if you knew that a horizontal tangent line means your derivative is equal to 0, and so that you set that derivative equal to 0, give yourself a point. To solve this, however, we need to maybe cross multiply, or maybe you just know that means the top is equal to 0. So we need to solve that for x. Well, y, we can just divide by that. So the cosine of x is equal to 0. So we need to go back to that kind of unit circle from 0 to pi, because that's where it tells me from 0 to pi. And think about your different values. So we know this is the ordered pair 1, 0. This is the ordered pair 0, 1. And this is the ordered pair -1, 0. And so if we want for this to equal 0, where cosine is 0, we know that cosine, those are our x values. This is the place at pi over 2 where cosine is equal to 0. So when x is pi over 2, right here, we know that our cosine is 0. So if you were able to find that x value, give yourself another point. Now, notice it says we have to find the coordinates of the point. That means they want an x comma y. We have just found x, but we need to go back and find y. So to find y, you're going to plug your x into the original. In order to find your y, take this x that you just found, which is pi over 2, and let's go plug it back into the original. And we're talking about this original right here, right there. So we'll come back here, and we're going to say, when we plug that in, 2y squared minus 6 equals y times the sine of x, but where x is, I'm going to put pi over 2. So that's going to be 2y squared minus 6 equals y, but we need to find out what the sine of pi over 2 is. And we already know that sine is the y coordinate, so we're going to put a 1 in for all that. So then that's just going to be y. Set it equal to 0, and 2y squared minus y minus 6 is equal to 0. So you're going to factor that trinomial. It's 2y and y. There'll be a 3 and a 2. I need to have a -1 for the middleman, so we're going to make that a plus 3 and a minus 4. So that means y is equal to -3/2, and y is equal to 2. But they just told us that y is greater than 0, so we can't consider that one. So our y value is 2, and the point that they want is going to be x, which we just found to be pi over 2 right here, and y is 2. If you were able to successfully find that ordered pair, give yourself a point. That is the point right there where the line tangent to the curve is horizontal. That's what the question asks for. So we'll just kind of tell them that's what we found. Okay, the last part, D part, says let's take that last point we just found right here, this pi over 2, 2. Is that point that we just found, is it a maximum or a minimum or neither right here? All right, in order to do this, we're going to have to think about how can we tell if something is a max or a min. So what we're going to do is we're going to use the second derivative, and we're going to use concavity. All right, if the second derivative is less than 0, then you will recall that you are concave down. Think about what concave down looks like. It doesn't hold water. So therefore, you would have a maximum. But if the second derivative is greater than 0, you're going to be concave up. And you're going to hold water. And so therefore, we would have a minimum value. So we need to find the second derivative and look at that value and see if it's positive or negative, and that will answer our question. So if I'm going to find the second derivative, now let's think about what that first derivative was up here. Remember, the first derivative was this right here. So I'm going to have the first derivative was, I'm going to write that over because I think it will help me to see it better. So if I'm going to do that, my first derivative is y cosine x. Let's see, my first derivative is y cosine x over 4y minus sine x. That's what the first derivative is. All right, now let's find our second derivative. So if I'm going to find the second derivative on this right here, I'm going to have to use the quotient rule. So the bottom, which is 4y minus sine x, times the derivative of the top. But doing the derivative of the top is going to involve some quotient rule again. All right, so that would be the first, which is y, times the derivative of the second. The derivative of cosine x is negative sine x, plus the second, which is cosine x, times the derivative of the first, which is 1. But we're implicit again. So I'm going to have to say, because I took the derivative of a y term, I'm going to have to put in y prime right there. Minus, so this is the bottom times the derivative of the top, minus your top right here, times the derivative of the bottom. So if I take the derivative of 4y, that's just 4, but I took the derivative of a y term, so I need to put the y prime. And then I'm going to take the derivative of negative sine x, which is negative derivative sine is cosine x, all over the denominator, which is 4y minus sine x quantity squared. If you were able to take that derivative right there, or even if you considered the second derivative, if you considered the second derivative, that looking at that, and that's going to help me know about concavity for max and mins, and you considered that, give yourself a point. All right, now we're going to plug in our values. So I'm going to take everywhere there is an x, we're going to put in the point. Remember that point we just had? That point was pi over 2, 2. So everywhere there is an x, I'm going to put in pi over 2. Everywhere there is a y, I'm going to put in a 2. So I will say 4, but where that y is, I'm going to put a 2. Minus the sine, but where x is, I'm going to put in pi over 2. Then here, where the y is, I'm going to put in a 2 times negative the sine of pi over 2 plus the cosine of pi over 2 times y prime. Okay, let's think about this. y prime is the first derivative. Well, isn't this first derivative like having a horizontal tangent? So we're going to put in 0. Everywhere you have the first derivative, we're going to put in 0 because it's a horizontal tangent. So minus, and then where y is, we're putting in a 2. Cosine x, we're putting in a pi over 2. 4, but again, here we go again. That's your first derivative. And remember, we're a horizontal tangent here. So we're going to put in a 0 for that. So put in a 0 minus the cosine of your x, which is pi over 2. All over the denominator, 4, but where you have a y, you're going to put in a 2 minus the sine of pi over 2 quantity squared. All right, so then I'm going to plug this in or solve this. So let's see, let's do this sine of pi over 2. So we know that the sine is the y, and we know that the cosine is the x. So very carefully, 4 times 2 is 8 minus the sine of pi over 2 is 1. Here we're going to have 2 times the sine of pi over 2 is 1. That'll be negative 1 because of the negative, plus the cosine of pi over 2 is 0. So I've got that. And then this right here, 2 times 1, I don't need my parentheses, plus 0, minus 2. The cosine of pi over 2 is 0. And then that's just going to be 0 minus the cosine of pi over 2, which is 0. All over 4 times 2 is 8, minus the sine is 1 squared. Okay, so that's going to be 7 for this. That's going to be negative 2 minus, and that's just all 0, all over 7 squared, which is 49. So negative 14 over 49, which I can take a 7 out, which is negative 2 over 7. If you got that value, give yourself a gold star. You should have gotten more points for that, shouldn't you have? All right, now we're going to also decide that the second derivative, so since the second derivative is less than 0 or negative, there is a relative minimum. If you were able to say that there's a relative minimum and give a reason for it, give yourself a point. There was also another point just for considering the dy dx. Maybe that's where that was right there, considering this y prime right there. All right, I hope you found this helpful for your AP Calculus exam preparation. If you did, please like, comment, and subscribe to the channel. Be sure to check out other AP Calculus question explanations as well as calculus tutorial videos on the channel. See you next time.